energy. Okay, uh, we have studied about the conversion of potential energy into kinetic energy today and different forms of energy, for which I had asked you to prepare the notes by yourself. Okay, today I'll be going through the conversion of one form of energy into another form, and then we'll deal with the exercises and the numericals. Now, we all know that in this universe, the energy is constant. It works on the principle of conservation of energy, which says that the sum total of energy is constant, and it can neither be created nor be destroyed, but it can be transformed from one form of energy to another. So based on this line, we study or we will be studying the conversion of one form of energy to another. We have basically different forms of energy which you have already studied. We will start with the conversion of mechanical energy into electrical energy. So, mechanical energy to electrical energy. Alright. One of the best example for conversion of mechanical energy into electrical energy is production of electricity through hydroelectricity. Okay, your hydroelectricity happens to be one of the prime example for conversion of mechanical into electrical. Now, in case of hydroelectricity, you see the water is stored in the reservoir in a dam. Okay, so stored water is going to possess the potential energy, and this has been allowed to fall over the dam. When it has been allowed to fall from a height, okay, so the falling water will be having kinetic energy. Okay, now potential energy and kinetic energy together we can call them as a mechanical energy. Now this water is made to fall on turbine, and the turbine rotates. Again, here we have the kinetic energy, and the rotation of turbine in turn makes the generator to work. Okay, the generator is connected to the turbine. Now, in case of generator, you will study in detail about generator in your electromagnetic chapter, magnetism. But for time being, I can tell you, or rather you are also aware, that it is basically when there is a changing coil, there is a changing magnetic flux linked to a coil, okay, it produces electrical energy. So basically, the generator is producing your electrical energy. We are able to produce this electrical energy. So you find that the mechanical energy is getting converted into your electrical energy. Okay, so this was your mechanical energy getting converted into electrical energy. The next is your electrical energy getting converted into your mechanical energy. Electrical energy to mechanical energy. As the electrical energy, the best example happens to be the working of electric motor. Of electric motor. Okay, in this case, a current carrying coil is made to rotate in a magnetic field, and that is how when the current is passed, it makes the coil to turn into a magnetic field, and hence the electrical energy gets converted into your mechanical energy. Okay, so in case of your electric motor, there is a shaft around which the coil has been attached, and this coil, when current is passed through this coil, you will find this coil is going to rotate. This coil is basically placed in a magnetic field. You have a coil which has been attached to the source of electric current. Okay, we have a magnetic field. So in this, we find that the current will be flowing through the coil, and this coil is attached along a shaft, and this shaft starts rotating. This coil starts basically this coil starts rotating, and since this axis has been attached to it, anything which has been attached to this will also rotate. So here, on passing the electric current, we find that it starts rotating. That is your kinetic energy. So electrical energy is getting converted into kinetic energy, or in other words, you can say that electrical energy is getting converted into mechanical energy. These motor, you will find its use or application in the various instruments and appliances at your home. For example, fan, working of fan, your mixer grinder, your washing machine. Okay, in case of cars, if you find the wheels have been rotating because there is a motor inside which makes this to rotate. Okay, so these are some of the examples where electrical energy is getting converted into your mechanical energy. Next example is electrical to heat energy. Next is your electrical energy to heat energy. Now, all the heating appliances at your home, whether it is a toaster, it is a heater, it is a room heater, or it is your geysers, all these are an example where electrical energy is getting converted into your heat energy. Okay, so here, when the current is allowed to pass through the coil, okay, the filament of the coil, electric press you have. So the filament gets heated up. That is a conversion of your electrical energy into your heat energy. Then there is an important fact, that is conversion of heat energy to electrical energy. Now, this is one of the important uh, observations. This has been done using device called as thermocouple. Thermocouple is an arrangement where the heat energy is getting converted into your electrical energy. Actually, thermocouple is basically a combination of uh, two different type of metals. Okay, uh, and they are being connected in such a way that one end behaves as a cold junction, whereas one end will be at a considered as a high temperature, that is your hot junction. Okay, these are the two metals, okay, having difference in their conductivity, having different in their conductivity. Conductivity. Okay. Now what happens? as the two ends are being maintained at two different temperature, one at a lower temperature, one at a higher temperature. Due to this difference in the temperature, the current is being conducted. It is observed that current is being conducted in this wire, and that is how we call it, or rather we say that it's the heat energy which gets converted into your electrical energy. So this arrangement is called as your thermocouple. Okay, thermo means heat. So there is a difference in the heat due to which the electricity is being conducted or is being produced. In other words, heat energy is getting converted into your electrical energy. So this is what the example of your heat energy getting converted into your electrical energy. Then we have the next form of energy is your electrical to sound. Electrical energy to sound energy. Okay. So for example, when you are listening to me at this moment using your earphone, using your external device, okay, it's basically the electrical energy is getting converted into your sound energy. It's basically the electrical impulses which are reaching, and there through your audio devices, okay, through your earphones, you there the sound, the electrical energy is getting converted into your sound energy, and you are able to hear. Sound box, okay, the music system, you will find that it is the electrical energy which is getting converted into your sound energy. Then we have sound energy to electrical energy. Other part, sound to electrical energy. In this case, if you observe, when I am speaking at present, it has been received by the mic. So my sound energy through mic, it is getting converted into your electrical energy. Now this sound is basically traveling to you in the form of electrical signals or electrical impulses. Okay, so if you take the complete set of mic and audio system, okay, mic and earphone for example, okay, or mic and speaker system. So when you are speaking, it's the sound energy getting converted into electrical, and that is being taking place in terms of your uh, microphone, okay, and then the sound energy is getting converted. The electrical energy is getting converted back into the sound energy through your speaker. Okay, so that is an example how the electrical energy is getting converted into sound energy, and sound energy is getting converted into your electrical energy. Similarly, we have electrical energy to the chemical energy. Next is your electrical energy Next is your electrical energy to the chemical energy. Now, at your home, you might be charging your battery, your inverter batteries. Okay, that is one of the example where the electrical energy is getting converted into your chemical energy. So during the process of charging, it's basically the electrical energy is getting converted and stored in the form of your chemical energy. And when you are using this battery, that time the chemical energy getting converted into your electrical energy. Okay, there are various other examples where you are converting the electrical energy into your chemical energy. Basically, the electrolysis, where you are allowing the electric current, and as a result of electric current, we find that there is a dissociation of the chemical compound, okay, into their constituent ions. So there also you can make out that the electrical energy is getting converted into your chemical energy. Hand in hand, the vice versa is also true. That is, chemical energy can also be converted into your electrical energy. Okay, as I told you, the primary cells, for example, if you take, okay, you are receiving the electric current from that primary cell, and that is how it has been used in your torch or in your various devices, okay, to provide you the electricity. So in case of a primary cell, if you observe, if you have studied about the primary cell, then you will observe that the energy, you observe that the chemical energy is basically getting converted into your electrical energy. For example, dry cell if you take, okay, in the dry cell we find that there are two electrodes of different reactivity. There is an electrolyte, and as a result of the chemical reaction, the potential difference is created. Detail will study in electricity chapter, and I hope you have already studied in 9th class also. So there what we find that is the chemical energy getting converted into your electrical energy. So dry cell, Leclanché cell, and even in case of your secondary cell, that is your lead acid battery, the batteries which you are using in your inverters, there also, when you are drawing the current, say when there is a power cut, so inverters are providing you the electricity, or inverters are providing you the power backup. So how this power backup has been given? This power backup has been given whereby the chemical energy is getting converted into your electrical energy. During the charging process, it is electrical to chemical, and during the discharging, that is when you are drawing the current, it is the chemical energy to the electrical energy. Then we have light energy to chemical energy. So light energy to chemical energy, various examples. One of the very basic example is when you light up a candle during your birthday celebration. Okay. So what is a candle? Candle is again a wax. Clear? Sorry. This is not an example of light to chemical. This is basically an example of chemical to light energy. First we'll do the chemical to light, and then we'll do the light to chemical. So in case of a candle, when you are lighting up a candle, candle is basically made up of a wax. Wax is a petroleum product, which is a chemical compound. Now, it's basically when you are lighting up, the vapors of wax, okay, the wax is getting converted into the vapor form due to the heat, okay, and this vapor catches fire, okay, and that is why this fire gives you light. So this is one of the example where we find that the chemical energy is getting converted into your light energy. There are many other examples. During your Diwali festival, you burst firecrackers, okay, various type of, and you find that there are various type of colored lights being emitted out. Okay, it's again the chemical which is present inside these firecrackers, okay, they react due to the heat when we are lighting up, and as a result of which it gives out the different type of light. For example, if you are burning burning a magnesium, it will give you a dazzling white. Okay, if you are burning a cadmium, say it will be giving you a pink. Some will give you green color. Some sodium if you are burning. Okay, that will give you golden yellow color. Okay, so these are the different type of light which has been provided due to the change in their chemical energy. So these are the examples of your chemical energy getting converted into your light energy. And similarly, we have light energy to chemical energy. You might have studied in chemistry. Okay, silver chloride solution, if you are taking, they should be kept in a dark color bottles. Okay, or sometime nowadays we are having the electronic gadgets to take the photographs, digital cameras we have. Earlier we used to have photographic films. Okay, the old classical or old cameras, if you see, they used to have films. Okay, now these photo films were basically, which we call it as, which we were calling it as negatives. They were basically the light sensitive. Light sensitive means they should not be exposed to light. Okay, if they are exposed to light, they get damaged. The reason is that they have been coated with the certain light sensitive chemical compounds. So when the light is incident on that, it gets reactive. As I gave you the example of silver chloride. Okay, if you keep them in the sun, you will find that its color will change, and rather there is a reaction, chemical reaction taking place. Such type of reaction we call it as photosensitive reactions or photovoltaic reactions. Okay, so there are certain chemicals which are prone to this light, and there we find that the light energy gets converted into your chemical energy during the chemical reaction. Another example, a very good example, is your process of photosynthesis. Now, photosynthesis takes place in the presence of sunlight only. Okay, so that is also during the photosynthesis, it prepares your food in the form of glucose, and glucose is a chemical compound, and therefore we can say that the light energy is getting converted to your chemical energy. Then we have electrical to light energy. Now, electrical to light energy, very simple example, your bulb, your CFLs, your nowadays LEDs. So whenever you are switching on the current, you find that the light is being produced. Basically, the electrical energy is getting converted into your light energy, and that is how you are able to receive the light. Then we have light energy to electrical energy. So every interconversion you will find there will be both the side interconversion. Now you must have studied about the solar cells. Okay, they are also called as PV cells or photovoltaic cells. Photovoltaic cells are those cells which are light sensitive in nature, which means that when the light is incident on them, they produce electric current. The elements like germanium, silicon, they are called as semiconductors, and these semiconducting elements, when they are being subjected to the light, that is your solar energy, there we find that this produces electric current. Okay, also the magnitude of the current which is produced, that is very very small, therefore we require large number of solar cells which have been connected in series with the panel, we call it a solar panel. Okay, but definitely whatever amount of light is incident, and accordingly whatever amount of electricity is produced, it's basically the light energy is getting converted into your electrical energy. Okay, similarly heat energy to mechanical energy. is one of the most important example, or one of the most common example, which nowadays we are not able to see, and I don't know how many of you have seen working of a steam engine. Okay, in case of a steam engine, you might have observed, okay, heat is being generated, okay, which converts the water into steam, and this in turn makes the engine to run. Okay, so heat energy end product is your mechanical energy, and as a result, we find that heat energy is getting converted into your mechanical energy. Now, if you have not seen electrical your steam engines, you might have seen the working of pressure cooker. The weight which is put on the pressure cooker, okay, when the pressure inside develops, it blows. Okay, so before it blows, it has to rise up. So it's basically the heat energy which in turn is converting the water which is present inside the pressure cooker into steam, and this steam again is hot, and it is making the weight to lift up and blow whistle. So that is another example of heat energy getting converted into your mechanical energy. Then we have chemical energy to heat energy, very common. Quite often we have observed, you have studied about your exothermic reactions. So, chemical energy to heat energy. So this is your exothermic reaction, where we find that, say for example, calcium, lime, if you take and put them into water, you find it will also generate heat. Okay, so this is an example of chemical energy getting converted into the heat energy. Firecrackers, again chemical energy to heat energy. Explosives. In respiration also we find that when you are breathing out, exhaling, you are giving out, along with the carbon dioxide, you are also giving out heat. So from where we are getting this heat? It's basically when you are breathing in, the oxygen going inside the body, and there's a chemical reactions taking place, and no carbon dioxide is produced, and this carbon dioxide is given out along with the heat. So that is also an example of chemical energy getting converted into your heat energy. Similarly, chemical energy to mechanical energy. The best example is your fuel, petrol, diesel, gasoline, kerosene. All these are your chemical, and they act as a fuel. Fuel is basically those substances which burn to give out heat energy, or which burn to give out energy. So here, in case of petrol, petrol is a chemical compound which on burning, which on undergoes the reaction, and it gives out energy which has been used to run the vehicle, and this running of vehicle is again a mechanical energy or kinetic energy in particular. So chemical energy getting converted into your mechanical energy. Then we have electrical energy to magnetic energy. So electrical energy to magnetic energy. So you might have studied about solenoids in class 8 as well as in class 9th also. So solenoid is basically an arrangement where if a current is made to pass through a coil, okay, in case of solenoid there is a number of coils, so it starts behaving like a magnet. Or even if a simple conductor you take and pass the current through it, and then some iron fillings near to it, you will find these iron fillings which will get attracted. It shows that magnetic field is generated. So this is an example where electrical energy is getting converted into your magnetic energy. Similarly, your nuclear energy to electrical energy, very common example, nuclear power plants. Now, we all know that there are two types of nuclear reactions which are taking place, fission and fusion reaction. Now, fission reaction has got two implications. Either it can be constructive, it can be destructive. Destructive is your atom bombs or nuclear warheads, but there is a constructive use of this also. The constructive use is that it can be converted into your electrical energy. So you might have heard of nuclear power plants. Okay, we have various nuclear power plants in India also. One is in Kalpakkam, in Tamil Nadu, Narora power plant we have in Uttar Pradesh. Okay, then we have one in Rajasthan. Now, in case of your nuclear power plants, is basically the nuclear energy is getting converted into your electrical energy. Now, working on the power plants, we have already studied it. And last year, some of you have demonstrated it also in your science exhibition. So, in detail, we'll study in nuclear radioactive chapter. So here, nuclear energy is being converted into electrical energy. Then we have the last one, mechanical energy to heat energy. Okay, you find that moving part, if your car is moving and you find that it's also the heat energy has been produced. Okay, if you keep on running the wheels or rotate the wheels of the cycle and you try to hold it, you'll find that heat will be generated due to the movement. Okay, so there are various examples where we find that there is a heat energy produced due to the mechanical energy. One of the example is that in case of dam, when the water falls from the height, okay, the temperature at the upper portion of the dam and the temperature at the lower portion of the dam will be different. At a height, it will be at a lower temperature, but when it falls down, the temperature will be slightly more. The reason is that along with the conversion into the potential to kinetic energy, some heat energy is also being produced, and that is why the temperature of water increases. Okay, so that is how we find the upper surface of the sea or river or any water body, the upper surface will be cooler, and as you go down, the temperature will be higher. Now, it doesn't mean that there will be a very vast difference, but still the water will be warmer towards the lower end and lesser towards the upper end. The reason is that towards the lower end, we'll find that due to the kinetic energy, due to the kinetic energy of the molecules, of the particles, of the water, they interact with each other, and as a result, some amount of kinetic energy gets converted into your heat energy. And that is how we can say that mechanical energy gets converted into your heat energy. This was about your interconversion. Okay, so a general interconversion which you all are aware of, just a brush up. Okay, but don't leave it. It's an important part. Every year, every alternate year, you will get one or two questions based on the interconversion. Simple questions are they? Okay. Now, one or two facts I would like to bring to your notice over here. The first fact is regarding your mechanical energy. The first is regarding your mechanical energy. is that whenever there is a change of the mechanical energy into your any other form of energy, it's basically the potential energy. If it is the potential energy which is getting converted, potential energy will always get converted into kinetic energy, and then this kinetic energy can be converted into various other forms of energy. So, in case of this, you can say that it's a potential energy to kinetic energy and then to the various forms of energy. Another important fact which I would like to bring to your notice is about the degraded energy. Okay, this is another important term which we are going to use. Quite often it happens, and whenever you might also feel. Okay, suppose if a question is asked, uh, working of fan. Okay, state the energy changes which is taking place or energy change which is taking place in the working of fan. So most commonly, you are going to write down that it is the electrical energy getting converted into the mechanical energy. Some may be writing down electrical energy getting converted into mechanical energy as well as heat energy. Some may be writing down electrical energy to mechanical energy as well as heat energy as well as sound energy, because you are able to hear some sound also. Now, which one is the right answer? So, all are right, because yes, the electrical energy is getting converted into your kinetic energy. If you touch the fan, you'll find it is getting converted into heat energy also. And since you are able to hear the sound also, okay, vibration will be taking place. So it is getting converted into sound energy also. So we were dealing with which answer is right and why the two answers are wrong. So if we consider the energy transformation we can take place in the two category. One is your desired form of energy. Desired form, undesired form, and third, some amount of energy is lost to surrounding. Okay, it may be from the desired also, it may be from certain part of undesired. Okay, now desired form of energy is basically that energy which is that particular interconversion should undergo. What I mean by saying that, this you can say it as useful energy. non-useful energy. Okay? Non-useful energy, or we also use a term, we call it as dissipation of energy. Dissipation of energy. Dissipation of energy is basically called as your waste energy or non-useful energy. Okay? Now what does this dissipation of energy do? This is basically not available to us for any productive work. Okay? So what we have two categories. One is your desired form of energy and the other is your undesired form or the energy which is lost. Okay? Now, desired form is what is useful. Okay? They are being used for the productive work. Whereas undesired and the energy which is lost to the surrounding, they are non-useful to us. And therefore they are called as your dissipation of energy and they are non-productive in nature. Okay, that means we are not able to use them for any productive work as per the requirement. This non-productive energy which we are getting, this non-useful energy which we are getting is only called as your energy degraded. Okay, or degradation of energy, degraded energy. Okay, so this is. Now let us try to understand with an example. I hope the definition is clear to all of you. Write down your comment on chat. I'll explain you through an example and then I'll come to the chat part and then I'll explain here. Okay. Now, I take an example of electric bulb. In case of electric bulb, if you observe, okay, the purpose of the bulb is to produce light. But do we get only light? The bulb. So, along with the light, it also produces heat because the bulb is heated up. Okay. Now, you will find that heat we do not require. I require only light. So light happens to be useful energy. Where this is non-useful. Whereas this is non-useful energy. Now what happens? So when you are writing down the conversion, I am not supposed to write down this part. So what conversion I will write? I will write down electrical energy to light energy. Okay. So this part of energy is your degraded energy. Now, it is not necessary that the degraded part, sometimes in most of the cases, if you try to actually observe, the dissipation of energy is more than the useful part. If you see the efficiency, when you study the efficiency of machine is 40% efficient. 40% efficient means out of 100% of work done on it, only 40% is getting converted into the productive work or the useful work. Rest 60% is your wastage. That is your dissipation of energy or energy degradation. Okay. So when you are writing down the interconversion of energy, you are only supposed to write down the useful energy. Non-useful part of energy you will not be mentioning over there. So I hope this is clear to all of you. Now, if you have a problem with this, we finish off the second portion of the chapter. And now we will begin with the exercises. But before the exercises, if you have any queries, uh, yes. The sound energy as a vibrational energy. Now see, vibrational energy, Ashutosh, Ranjan. Sound energy as a vibration. Now, vibrational energy are generally considered to be kinetic energy. Now, various type of kinetic energy we can have. Okay, rotational, vibrational, and your translational energy. But when we are talking about the sound also definitely it is going to be created due to the vibration. But when particularly if I have to talk about sound, so I'll have to mention the sound energy. Okay, so therefore you should not be writing down the vibrational energy for sound energy. In case of photochemical cells, it's basically light sensitive. Okay, the light has been incident and there are certain electrons which have been emitted out due to which the current has been conducted. And since the magnitude of this current happens to be very, very small, okay, it has been said that, say, for example, if I take 2 centimeter square of a silicon, then I will be getting energy, electrical energy, around about 0.02 joules only. Okay, so a very, very small quantity of energy we are able to receive, and therefore we require a lot of photovoltaic cells to work on it. Okay, so I hope this is clear. Yes, you can have a better idea in this case. Mohammad Arsh, sound energy, if it can be stored, yes, we all know that it has been observed that whatever we speak that remains in this universe, okay, but harnessing that sound energy becomes very, very difficult. Storing that sound energy has got some practical difficulties. But yes, definitely we can use this sound energy to produce electrical energy just like we are using. So maybe in certain period, or maybe you might find out a way to store this sound energy and can be utilized for electrical energy. That can happen. So next time if you are having a science exhibition, you can work on it during this period. Try to see through what means we can store this sound. If we are able to store this sound, then definitely we will be able to convert it into electrical energy. So, but first of all, we have to see how can we store the sound which we are producing, or a lot of sound which are being produced. Okay, that's fine. Coil and pass a current. Actually, it has not failed. Actually, when you are rotating a shaft, the amount of electric current which is produced, that is all very, very small magnitude, may not be able to detect it. Okay, that is why what we require a RPM, the huge RPM, that is the rotation per minute should be large enough so that it is able to produce a considerable amount of electric current. Say for example, a simple generator if you are taking. As you increase the size of the generator, you will get the wattage of the generator. Okay, a small generator will be producing a small wattage, maybe light can be you can use it for just one room. But for a huge one, you require a huge generator. Actually, we are not storing it in OS, it is remaining. based on the conservation of energy. Okay, so whatever we are speaking, it is still in the universe, but how and which form, that has to be uh, found out still. Candle and gas stove can also be an example of chemical to heat energy. Yes, gas is also candle and gas is chemical energy. There also you can say that it's the chemical energy getting converted. Gases are also vapor energy. What you can say that it's again the kinetic energy. So we don't give the name as a vapor energy to any of this. Okay, either we use it as a chemical energy, or if we are talking about the kinetic energy, then we will be talking about the kinetic energy only. So word vapor energy, the term vapor energy is not being used, but definitely when we are converting, say for example, steam, water into vapor, especially in form of steam, so that has got energy which is a kinetic energy. So I hope Manasvi, your query is clear. Okay. So we are already 4:55. So I will not be starting with the numerical part. I thought of we'll do it in the next class. Meanwhile, you try to attempt the numericals from this section, that is 2B. Exercises also you can do. From exercise 2B, we have the question that is theory part. You can do question number 5. I'll put them in the snap also. Question number 5, 7, 10, 15, 17, 18, 19, 20, 24, 25. Okay, you let me. Where you have studied about the vapor power plant. Is there any example where all the energy is used and there is no unuseful? No, no. Practically, this is not possible. Some or the other, because resistance friction is always there. So some amount of energy is getting. Yes, you can have say 90%, 99%, especially in case of superconductivity. Okay, when we are talking about superconductors, we have we say that practically it has got no resistance. Okay, that is why it is called as a superconductors. But that is under a controlled condition. That is under in this at a very low temperature. Okay. Otherwise, in the normal condition, no. Is there any other question? Now, today I have taken your name and I find the participation is too less today. I don't know why, but please inform your friends also, because this will be considered as an absentee. Okay, so please all of you attend the classes, and we'll see that all those who are not attending, I may call your parents also to tell that they are not attending the classes. So please. रिसीव करो तो मेरे बात हो. Okay, so